Okay, so we've discovered that Bohr's model had a whole bunch of problems. So what we move into next is called quantum mechanics. I'm sure you learned about this in your first year chemistry course. This slide right here is really just to show you why I'm not going to show you where the math comes from. Okay, because you don't know how to take second derivatives of wave functions, so you're just going to have to take my word for some of this stuff. Okay, quantum mechanics basically tries to describe, instead of exactly where the electron is, the probability of finding an electron in any given area of space. Okay, this diagram right here is just showing you all of the black dots, show you where there's a high probability, so you can see as you get farther from the nucleus, the probability of finding an electron decreases, which isn't particularly surprising, right, because the nucleus is positive. So the dude's name's Erwin Schrödinger, and he gave us basically, you know how when you solve the quadratic formula you get 2 solutions? Well, when you solve his equation you get 3 solutions, and each one of the solutions tells us something about where we might find an electron. So the first one is the principal energy level, and this is the same energy level that Bohr gave us. So n can equal any integer, 1, 2, 3, 4, whatever. Okay, so this is nothing new, the same as Bohr. Lower energy level, or ground state, is n equal to 1, and any higher energy level is some higher number. The second solution tells us the sublevel. Now there's rules, so I'm going to be honest here. If you're not taking the AP exam, don't worry about the rules. If you are, I'm afraid you're going to have to learn them a little bit, okay? Sublevel, which is L, can have any value from 0 through n minus 1. So for instance, that's not as hard as it looks. If n is 1, L can be 0. By the way, you already know L equal to 0 by another name. You call it the S sublevel. Okay, so you already know S. You've heard that letter before. If n were 2, L could have 2 values, 0 or 1. 0 is the S sublevel, and 1 is the P sublevel. If n were equal to 3, then L can have 3 different values, okay, which hopefully you have learned as the S, the P, and the D. So L equal to 1 just means S, L equal to P, 0 S, 1 P, 2 D. Okay, and then if n equal to 4, L equals 0, 1, 2, or 3, okay, which corresponds to S, P, D, or F. Okay, and you've heard of S, P, D, and F when we write electron configurations, which is the whole point of where we're going with this. So there's some rules, but really our whole goal is just to get toward electron configuration. So you might notice that whatever the energy level's number is, that's the number of sublevels it has. So for n equal to 1, it has 1 sublevel. For n equal to 2, it has 2 sublevels. N equal to 3 has 3 sublevels. N equal to 4 has 4 sublevels. The third solution to his equation tells us about the orbitals. Okay, not orbits like Bohr told us about, orbitals. An orbital is just an area or a shape in space where there's a high probability of finding an electron. Okay, its symbol is m sub L. And again, there's rules to this, which if you're not taking the AP exam, you don't have to memorize. If you are, you're going to kind of have to know this. Okay, so if L were equal to 0, which we just said was an S sublevel, then m sub L can also equal 0. And this is called the S orbital. So the S sublevel has an S orbital. Now an orbital is just a shape. And in a minute we're going to look at those shapes, which I think you've seen. An S is just a sphere. If L equal to 1, which is a P sublevel, that means, so minus L to plus L, it could be minus 1, 0, and 1. So P sublevels have 3 pieces. And you might have learned them as the PX, the PY, and the PZ. Okay, or you might just somewhere in your distant memory have a picture of like flower petals or barbells or something. We'll look at that shape in a minute. L equal to 2, which is your D sublevel, has 5 pieces. The dxy, the dyz, the dxz, the dx squared minus y squared, and the dz squared. Yes, I said that fast. Don't memorize it. Okay? The F sublevel has 7 pieces, okay? So we have 1 piece, 3 pieces, 5 pieces, and 7 pieces. By the pieces, I mean orbitals. And in a minute, we're going to discover that you can put 2 electrons in each orbital. That's why S sublevels get 2 electrons, P sublevels get 6, D get 10, and F get 14. So these are your shapes, okay? This is your S, okay? It's just this, it's like a ball. It's a spherical shape. If that were the 1s, the 2s would simply be a bigger sphere, okay? The P orbitals, so each P sublevel has 3 pieces, the PX, the PY, and the PZ, and they're just like these figure 8 or flower petal things. The PX is simply oriented along the x-axis, okay? The PY is oriented along the y-axis, and the PZ is oriented along the z-axis. So the P sublevel has 3 pieces or orbitals to it, and each orbital can get 2 electrons, so you can see where you might get 6 electrons. So there's 1, 2, 3, 4, 5, 6, okay? The D orbitals are a little more complicated looking, okay? These 3 on the top are the DXZ, okay? The DXY and the DYZ, whatever, it doesn't matter. And then the dx squared minus y squared and the dz squared. It doesn't matter. Basically, they're just shapes in space that are predicted by his equation, where there's a high probability of finding an electron, okay? No one is ever going to ask you to draw d orbitals, okay? The f orbitals are even more complicated, okay? But here's the whole set of them. So up top we have the s's. So the whole p sublevel would have all 3 of these. The d sublevel would have all 5 of these, and the f sublevel would have all 7 of those. Again, no one is going to ask you to draw d or f sublevels. I'm not going to ask you to draw S or P, and I don't think anyone is, but they're simple if you did need to. The last thing that we get from quantum mechanics is not from the equation, but from another source, and that is that electrons are spinning. They're rotating about their axis, either clockwise or counterclockwise, and they're given a value +0.5 or -0.5. Clockwise, counterclockwise, okay? And then Pauli, hey Pauli, he came along. Pauli exclusion principle basically says that no 2 electrons, okay, can have the same 4 quantum numbers. Okay? Those are quantum numbers we're talking about. The N, the L, the M sub L, and the M sub S. So since there's only 2 values of M sub S, you can only put 2 electrons per orbital. Okay? So the next video, what we're going to do is, that's great, terrific, don't spend a lot of time worrying about it. Okay? Instead, we're going to go to the next video where we learn how to write electron configurations and orbital diagrams, which I know you've seen, and it will come back very quickly, I think.